In both math and computer science, whenever we learn about a structure, it's useful to then learn how to build new structures out of it. We're going to do that now by looking at 5 operations we can perform on sets that will create new related sets that can be used for various purposes. As a running example throughout this video, suppose you're in a discrete math class. Let's let U be the set of all students in the class. Also, let C be the set of all computer science majors in your class, and F is the set of all first-year students in the class. So C and F are both subsets of U, but we don't necessarily know how C and F relate to each other. The instructor of the class wants to let all the first-year computer science majors know about the computer science club. So she needs to generate a list of all students in the class who are both computer science students and first-year students, all students who are both in the set C and in the set F. This is called the intersection of those two sets. In general, the intersection of any two sets, A and B, is a new set whose elements are those that are elements of A and elements of B. We use an upside-down U symbol like this to represent the intersection of A and B. That symbol should remind you of the upside-down V we used for AND when studying logic. We'd express the intersection of A and B like this in set builder notation. In our class, C intersect F would contain these 3 students, since they are the ones in both sets at the same time. Later on, the instructor gets a message from the university asking her to remind students about signing up for classes. She decides she needs to especially contact any student that is either a first-year student or a computer science major, since first-year students may need to be reminded about signing up for classes, and computer science majors have a complicated set of courses to finish. So this time, she needs students who are either first-year students or computer science majors, or both. This is called the union of those two sets. In general, the union of any two sets A and B is a new set whose elements are those that are either elements of A or elements of B, or both. We use a U-shaped symbol to denote the union, and here's what it would look like in set builder notation. For our class, C union F would contain these 8 students, since they are either in C or in F, or in some cases both. Not all the students in the discrete math class are computer science majors, and the instructor would like to send the first-year students who are not majoring in computer science some information about the computer science major to see if they're interested. Now the instructor needs the students who are first-year students, but who are not computer science majors. This set of results is called the difference of the two sets. In general, if A and B are sets, then the difference of A and B is written either with a minus sign or with a backward slash, and either way it's pronounced A minus B. This is the set whose elements are those that are elements of A and are not elements of B. In our class, we're looking for students who are first-year students, but not computer science majors. So that's F minus C, which in this case has 3 students in it. Notice that unlike with intersection and union, the ordering matters here. C minus F is different. This would be the set of students who are computer science majors, but not first-year students. The instructor of the discrete math class decides it would be good to send that information about being a computer science major to all students who are not currently majoring in computer science, not just the first-year students. So now she needs a list of all students who are not majoring in computer science, regardless of what year they are in. This is called the complement of a set. In general, if A is a set, then its complement is a new set whose elements are those that are not in A. We use a bar over the name of the set to denote its complement. In our class, the instructor needs the complement of C. That's the set of all students not majoring in computer science. That's this set of 7 students. Notice that in order to find the complement, we needed to know what the entire set of students in the class was. We called that set U, and the set of all elements we are considering in any given situation is sometimes called the universe. So notice that the complement of A is just the difference U minus A, and the difference A minus B is the intersection of A and the complement of B, the set of all elements that are in A and not in B. Going back to our discrete math class, it turns out that the computer science department has its own message to send out about class registration to all the first-year computer science majors. So the instructor of the class didn't need to send the information to those students. She needed to send it to the students who are either computer science majors or first-year students, but not both. The set of students in that situation is called the symmetric difference of two sets. In general, if A and B are two sets, then their symmetric difference, which we notate with a triangle symbol, is the union of A and B minus the intersection of A and B. The set whose elements are either in A or in B, but not both. In our class, the instructor would need the symmetric difference of C and F, which would be this set. Now you try it. Let A be the set 1, 2, 3, 4, 5, B the set 3, 4, 5, 6, 7, and C the set 1, 2, 8. Assume that the universe, in this case, is the set 1 through 10. Pause the video and write out the following sets in roster notation. A intersect B, B intersect C, A union C, A minus B, A symmetric difference B, and finally A intersect the complement of B union C. So A intersect B is the set of elements in both A and B. That's the set 3, 4, 5. B intersect C is the set of elements in both B and C, but there are no elements in both, so that set is empty. Whenever two sets have an empty intersection, we say those sets are disjoint. A union C is the set of elements in either A or C or both, so that's 1, 2, 3, 4, 5, 8. A set union is a little like merging the two sets and then removing duplicates. A minus B is a set of elements that are in A but not in B. Well, A consists of 1, 2, 3, 4, 5, and 3, 4, 5 are in B. So we throw our 3, 4, 5 out and we are left with 1, 2. So A minus B is like a filtering process where we start with A and filter out any of the things that are in A that are also in B. A symmetric difference B is A union B, which is 1, 2, 3, 4, 5, 6, 7, minus A intersect B, which is 3, 4, 5. Filtering out those three elements leaves us with 1, 2, 6, 7. Now for the last one, we build the set piece by piece using order of operations. B union C is the set 1, 2, 3, 4, 5, 6, 7, 8. The complement of this is everything in the universe set that isn't in B union C. So that's 9, 10. Then A intersect with this set is empty, since those two sets have no elements in common. So in this video, we introduced 5 set operations: intersection, union, difference, complement, and symmetric difference, and saw how these can be used to combine sets in different ways for different purposes. In the next video, we'll discuss a 6th operation called the Cartesian product of two sets that produces a very different kind of result.